Hi, in this video, I'm going to continue graphing quadratic functions and all the using the important parts using the form y is equal to ax squared plus bx plus c. So we can see that this function is actually in standard form. And remember that if it's not in standard form, we must put it in standard form before we start finding and using our coefficients. Okay, so it looks like we're going to follow the same steps in order to graph it. First, we need our axis of symmetry, but first let's identify the coefficients. So in this case, a is equal to 1, and it looks like b is equal to -3, and it looks like c is equal to -10. So what we're going to do is we're going to graph this function using these coefficients. So let's find the axis of symmetry, and we need to memorize that equation. X is equal to -b divided by 2 times a. Well, negative, and then remember that b is negative, so we have to insert it just as it is when we substitute -3 divided by 2 times 1. So that will give us 3 divided by 2, and so that will give us a positive 1.5. So let's go ahead and graph that imaginary line on our graph. It's at positive 1.5. So different from the last one, it's going to be between the x values of 1 and 2. And so it's going to be halfway, so as halfway as you can get it. Hopefully your hand is not shaky like mine. So x is equal to 1.5, and so let's label that. Okay, so we have the middle of our parabola. So now let's find its vertex, which passes through the middle line. Okay, so we're going to use the axis of symmetry to find our vertex. So we're going to take the x value. We know that our vertex value will be 1.5 comma some y value, and we need to find that y value so that we can plot that point. Okay, so we're going to use f of positive 1.5 is equal to, and our equation was 1.5 squared minus 3 times 1.5, and everything's replacing x, minus 10. So go ahead and take a minute and put that into the calculator and find it. You can pause the video if you need to. Okay, so you should have gotten that f of 1.5 is equal to negative 12.25. Okay, so that's a pretty big number, and it looks like it's going to be off our graph, but what we can do, since we haven't started graphing anything else, is we can actually change the scale of our y-axis. So what I'm going to do is I'm going to go in 2. So this one is 2, 4, 6, 8, 10, 12, 14, which would make this -2, -4, -6, -8, -10, -12, and -14. Okay, so that's going to make that a little easier for me to graph. And so I'm going to graph in a very thin pen. And so it looks like the point that we need is 1.5 for the x value and a coordinate of -12.25 for the y value. So 1.5, -12.25. We know that's going to be pretty small. 13 would be here, and so half would be here, and so -12.25 would be about there, just under 12 at the scale that we're using. So it would be about there. It may not be perfect because it's a decimal, but we can get it as close as we can. Okay, so now let's find some other points. We need our y-intercept. Remember, we said that if our equation is in the standard form, y equals ax squared plus bx plus c, then we can take that c value. So in this case, our function is y equals x squared minus 3x minus 10. So we can take this minus 10 value, and that will be our c. So our y-intercept is -10, or we can write it as a point, and we write that as 0, comma -10. And if you need to, you can still plug in 0 into this equation. So if you put 0 in for x squared, if you put 0 in for 3, this would go to 0, this would go to 0, and so you'd still be left with -10 as your y-intercept. Okay, so let's go ahead and plot that. 0, -10. So that would be here. And let me use that same orange color that I was using before. Okay, so there we have 2 points. And remember, let's use symmetry. So if the middle of our line is to the right and it's 1.5 away from this point, this y-intercept, then on the other side of the axis of symmetry, there should be another point that's the same distance away as the axis of symmetry. So in this case, it's 1 x value, 1.5 x value. So if we go a half x value and 1 x value, then we have another point that's the same distance. They're both 1.5 away from the axis of symmetry. Okay, so remember that distance should be from the axis of symmetry because that's your middle, and so everything on the parabola should be symmetrical. Every point should be symmetrical. Okay, so now let's determine if we have x-intercepts and how many we have. So we're going to use the discriminant b squared minus 4 times a times c. Okay, so b was -3, so -3 squared minus 4 times 1 times -10. And so in this case, I get 9, and then -4 is negative, times 1 is -4, and then times a -10 will be positive 40. So that's going to give me a positive 49. So yes, this is greater than 0, so I have two x-intercepts. So let's now use the quadratic formula to find them. We know that x is equal to -b plus or minus the square root of b squared minus 4ac, all divided by 2a. And we've already found the 4ac, so let's put everything else into our equation. X equals -3 plus or minus the square root of 49, all divided by 2 times 1. Okay, so now let's simplify this. So this is going to be a -3 times a -3 will be a positive 3, plus or minus, and the square root of 49 is 7. And 2 times 1 is 2, right? So we can split this into two x-intercepts. So I have 1 in the case that 3 plus 7 is divided by 2, and that would give me 10 over 2, which will give me an x-intercept of 5. And the other case is that x is 3 minus 7 divided by 2, and so that would give me a -4 divided by 2, which would be -2. So I have an intercept at 5, 0 and -2, 0. So let's go ahead and plot those points. 5, 0, 1, 2, 3, 1, 2, 3, 4, 5, and then 1, 2, -2, 0. So we can see that it looks pretty symmetrical from the y-intercept. So if we connect those points, we get something that looks like this. And it looks the same on both sides. So if we were to fold this parabola over that line of symmetry, we would get the same result on both sides, and all the points would be equidistant, the same distance away. Okay, so this is our graph. Let's label our important points. Remember, we had a y-intercept of 0, -10. We had a vertex of 1.5, -12.25. We had an extra point, which was 3, -10. We had another point of, it looks like 5, 0, our y-intercept, and then our x-intercept, sorry. And our other x-intercept was -2, 0. So all of my points are labeled. I have 5 points, and so I'm good to go. Alrighty, see you in the next video.